one is on solving linear equations. So this is kind of extending what we already talked about. So we had done some linear equations similar to this last time. So if you have like 2/3 x minus 5 equals x plus 7, we want to get all of the things that have x on one side, all the things that are just numbers on the other side. Okay, so the first thing I'm going to do is I'm going to deal with the x's first. And I have 2/3 x and I have 1x, and I usually try to get them so that they're not negative, if possible. So I'm going to go ahead and subtract the 2/3 x over, because that's less than 1x. And then remember, off to the side, if you need to do some scratch work, you can. So what we're doing is 1 minus 2/3, which is really 3/3 minus 2/3, right? 1 is the same as 3/3. So 3/3 minus 2/3 gives us what? Crickets. 1/3. You got it? 1/3 x plus 7, like that. So we have all the x's on one side. We combine our x's. So now we want to get all the numbers on the other side. So I'm going to subtract my 7, subtract my 7. So when I do that, I get negative 12, right? Negative 5 minus 7. It was already negative 5 to begin with.
Oh, yeah.
Yep. So I have negative 5 minus 7 is negative 12, and that equals 1/3 x. So this is where a lot of my students will say, oh, the answer is negative 4. And the answer is not negative 4. You have to be careful. You're saying 1/3 of a number gives me negative 12. So if I take a number and I divide it into 3 pieces, I'm going to get negative 12. What number would that be? Right? Yeah. Yeah, it's negative 36, right? So what we have to do is when we have a 1/3, what we multiply by is 3/1. We multiply by the reciprocal, or multiply by 3. Because the operation that's happening here, when we do 1/3 x, is it's x divided by 3. That's what we're doing. Guys, stop talking. Yeah, Peter.
I have a new piece of paper because I kind of ripped mine while I was erasing.
All right, right here.
Thank you.
All right, so we end up getting negative 36 equals x, and that's our answer.
Thank you.
All right, so on this other one, I have 3/4 x plus 2 equals 1/4 x plus 10. So I didn't have any simplifying that's happening on the left-hand side or the right-hand side. Guys, shh. So I don't have any x's I can combine on the left side. I don't have any x's I can combine on the right side. So this is where I start bringing things to other sides, right?
Yeah.
So if I have 3/4 and I have 1/4, which one is bigger? 3/4 versus 1/4. 3/4, right? So we're going to subtract the 1/4 over. So go ahead and try this problem along with me. Remember, be active note takers. Try it along with me. So when we subtract 1/4 x, we have 3/4 minus 1/4. Well, this already has common denominators for us, so that's nice. So we get 2/4, but do you think I'm going to leave it as 2/4? No. So let's reduce. So it's really 1/2, right? 2/4 is 1/2. So I'm going to get 1/2x plus 2 equals 10. Okay, so I've combined my x's. Now I need to combine my numbers. So I'm going to take my 2, and I'm going to get it away from the x. I'm going to take it to the other side of the equation.
Wait, why do you have it over the...
Why do I do the line?
Yeah.
Sometimes the line kind of helps you organize your thoughts. So I'm saying, okay, subtracted 2, what's my result? So I get 1/2 x equals 8, like that. So again, what we're thinking is half of some number gives me 8. Half of what number gives you 8? Half of 16, right? Some of you guys can do that in your head. You don't need to show the step where you're multiplying by 2, Colin.
Yeah.
Write some notes down. So we're going to multiply by 2, multiply by 2. So when we do that, we get x is equal to 16. Okay, and that's our answer. Man, you guys had an extra hour's sleep and you're just acting crazy today, aren't you? You're just, the girls are like, whatever, we're never act crazy. All right, next page. So it says some equations can be super scary at first. So a lot of you guys, like we talked about, have fraction phobia. You see fractions and you freak out. So if you have tons and tons of fractions in an equation, some of you guys just shut down and don't even want to try the problem. Okay, we're going to be better than that. We're not in middle school anymore. We're in high school. We can do these. So it says, actually, there's a shortcut that allows you to clear fractions. So we're going to learn that shortcut today. So it says all you have to do is multiply each side of the equation by the number that would have been the common denominator for each term. So in the last two examples, we dealt with the fractions, right? We subtracted 1/4 x, 1/4 x. We were fine. You guys can do it that way if you want to. Not a big deal. But do you guys like shortcuts?
Yeah,
I like shortcuts. And if there's a way to do this faster, then I want to learn it. Okay? So looking at all of the denominators in this first problem, we have 4, we have 8, we have 8. If I was going to change all of my fractions so they had the same denominator, what would that denominator be?
8.
It would be 8, exactly. So that's the least common denominator, LCD, is 8. So we know that equations are like a big teeter-totter. Keys. So when I add 2 to one side, I need to add 2 to the other side to keep things balanced. I can't like add 10 and then not add 10 to the other side. It doesn't keep things balanced, right? So if I'm going to multiply through by 8, I'm not only going to do it on the left-hand side, but also the right-hand side. Okay, so we're going to do a big parenthesis. So I'm going to do 8, and then I'm going to do 3/4 x plus 5/8, and I'm going to do 8 times 7/8 x plus 1. And many of you guys are going to be really good at this. You're not going to have to write this next step, but I'm going to go ahead and show you what we're doing. So this 8 is going into both pieces, right? So what we're saying is 8 times 3/4 x plus 8 times 5/8 equals 8 times, we distribute it here, 7/8 x plus 8 times 1. Okay, do you guys see how I multiplied the 8 into every single thing? That's what we're doing. So 8 times 3/4 x, 8 times 5/8, 8 times 7/8 x, 8 times 1. And the reason I do that in this class, I don't typically do this like in Algebra 2 and so on, because they just kind of know that it's 8/1, right? Is you can start canceling then. Okay, so I don't really tell people to cancel like this, because then they get a little bit crazy and they change their numbers before they get to the next term. And they forget all about that other term, okay? So, but here you can cancel. So 8 and 4 make 2. So you have 2 times 3, which is 6. So we get 6x. Now, could you have done 24/4? Sure. 24 divided by 4 is 6. Same thing. So the next one, we would have 40 divided by 8. Or you can cancel out the 8's, right? 8 and 8 make 1 and 1. So we get 5/1, which is 5. Same thing over here. What do I get here? Cancel, cancel.
7.
7x, and then over here, plus 8. If you do this correctly, you will not have any fractions at all. Okay, so if you multiplied by the least common denominator, then all of your fractions are going to go away. Is this a much easier equation to solve? Yes, and these are the types of equations. AJ, Colin, stop. Do I have to separate you? I will give you a seating chart. I did in my 7th period class already. All right, so I'm going to go ahead and I'm going to solve this. And this is just like we did the other day. These are pretty easy linear equations. We have x's on each side. We want to subtract our 6x, subtract our 6x. So see if you guys can do this from here. Okay, you should get x equals -3. Did you guys all get x equals -3? Colin, put it away. All right, does this make sense? All right, so let's try it on the next one. So what would our least common denominator be if we had 3, 6, and 2?
6.
It's 6, exactly. LCD is 6. So we're going to multiply both sides of the equation through by 6. So what we have is 6 times 1/3 x minus 1/6 equals 6 times 5/6 x minus 1/2. So you can show that step where the 6 goes into everything. You know I'm facing you, right? I see you guys the whole time.
I'm not talking right now.
You're just waiting for me to turn around, but I don't ever turn around. I'm just looking at you the whole time. All right, so we multiply the 6 in. So when we multiply the 6 in, it goes in each thing. So you can show that step where you have 6 times each thing, 6 times each thing if you want to. Do you guys think you can do it without writing that step?
Yeah.
So let's think about it. If you have 6 times 1/3, so you have 6/1 times 1/3. You would have 6/3. Do you guys see that?
Yeah.
6/1 times 1/3. 6/3. What is 6/3? It's 2. So we get 2x. The next one we have 6/1 times 1/6. What do we get? Yeah. So -1 equals, so 6/6 was 1. And then we have 6/1 times 5/6. Well, what's that? 6/1 times 5/6. It's 30/6.
You could simplify the...
Yeah, you could simplify the 6's, right? But both of them. So you get 5, right? So 5x, and then 6 over 1 times 1 over 2. So 6 over 1 times 1 over 2. You can cancel, or you could multiply across to begin with and get 6 over 2, but 6 over 2 is 3, so we have minus 3. So be careful with your signs, too. So you should get 2x minus 1 equals 5x minus 3. Yeah? Yeah, you're fine. All right, so we're going to solve for x. So it's already simplified. Simplified on each side, we're good. I'm going to subtract my 2x, subtract my 2x. I get negative 1 equals 3x minus 3. And I continue to solve. So I have x's on the right side, so I'm going to take my plus 3 and plus 3. What's negative 1 plus 3? Negative 1 plus 3. Yeah. 2. All right, and then I divide by 3. So your answer is going to be, so do you guys see why we're dividing by 3? Because we have 2 equals 3x. So we divide by 3 to get rid of the 3. 3 times, so do opposite operation, so we get x equals 2/3. Okay, so don't be scared if you don't have numbers like x equals 7, x equals 10. Sometimes they're fractions. Okay, so I want you guys to try the next one. Oh, I guess we have decimals this time. All right, we'll go and do this one. So it says the same is true for decimals. So you can solve the long way by keeping your decimals in the answer. So that's kind of like we did on those first 2 examples. We kept the fractions in our answer, and we were fine with it. You guys can handle fractions. So same with decimals. So if I'm getting my x's together, I'm going to take my smaller x and subtract it over. So 0.25x. And I subtract it over. So when I do that, I have negative 7 equals, what do I have here? 0.35 minus 0.25. Can you guys do that without a calculator? Yeah, what do you get? 0.10, right? 0.10. Or you could just write 0.1 and it would be the same thing. So 0.10x plus 12. We subtract the 12 over, subtract the 12 over. So we get negative 19 equals 0.10x. And so now here's where, if you think about what a decimal is, how do you read this? If I do 0.10, that's really 10/100ths, right? Or you could write 0.1x, which is really 1/10x, right? So when we got to this step before with fractions, when I had 1 over 10x equals negative 19, how did I get rid of that 1 over 10? What did I multiply by? 10, right? So the same thing here. We multiply by 10. Multiply by 10. So our answer should be negative 190. All of that without a calculator. Okay, so you don't need calculators to deal with decimals. It's actually much easier to use fractions. Fractions are your friend. I always say that. All right. So if you were doing this with a calculator, so go ahead and get your calculator out. If you had a calculator, I would just do negative 19 divided by 0.1 on your calculator, and you do get negative 190. Because we're dividing by a fraction. Remember when we divide by 1/2, it actually makes it bigger? All right, dividing by 1/2 makes something we multiply by 2. So when we divide by a fraction, we do get a bigger number. All right, you guys try this next one. So same thing. Be careful though. Remember that when you see 5.1, it's really 5.10x if you needed 2 decimals. So use that fact to help. Colin, I'm going to take it. All right, then use something else as a calculator. You may use my calculator.
Thank you. It's a huge calculator.
It is a huge calculator. All right, so try to do most of it, if possible, without a calculator. So a lot of the adding and subtracting you guys are fine on. Dividing with decimals is not always the most fun, so I probably would put something like this on a calculator section. So as we're going to combine, notice how we have negative 1.25x and we have positive 3.12x, and these are on the same side of the equation, right? So if they're on the same side of the equation, we're just going to combine them just as they are. So I'm going to have positive 3.12 and minus 1.25. So when we do that, we carry, right? So I get 7, make that a 0, carry the 1. So I have 10 minus 2 is 8. And then I line up my decimal points, right? So I have 1.87, because I had 2 minus 1. So I get 0.4 plus 1.87, because the 3.12 number was bigger. Do I need to email parents?
No.
And I get equals 5.1x minus 10. All right, so I have 5.1x, and I'm subtracting the 1.87x over. So I'm going to subtract this over. And now we have 5.1 minus 1.87. So a lot of times people mess this up because they forget they line up the decimal places. So I don't know what they do. like this. Don't line them up that way, right? We can add a 0. So it's 5.10 minus 1.87. You guys see how the decimal point places line up? So put a 0 in if needed. And then subtract. So we get a 3, because that was 10 minus 7. Carry from there. So 0, 1. Carry. So 10 minus 8.
Negative 1.87.
So I'm subtracting that from both sides. So when I do that, I get 3.23x.
I know, but how do you even get the negative 1.87?
Oh, when I combine these, I had 1.87. I did 3.12 minus 1.25. So I get 3.23x minus 10 equals 0.4. And then we add the 10 over. So when we do this, we have 10 plus 0.4. It's really 10.0 plus 0.4, right? So we get 10.04, or 10.4. I keep saying 10.04. 10.4 equals 3.23x. Now this is the part where I would think like it's probably acceptable if you guys use a calculator, right? Because what we're doing is we want to divide by the 3.23 to leave the x by itself. And if we were doing this, it's kind of annoying. Remember doing this at the beginning of the year? Divided by 3.23. And you would move the decimal place over twice. Move the decimal place over twice. So you'd really have 323 goes into 1,040 how many times? So I know it's going to be like 3 point something. Okay, but I'll let you guys use your calculator. So what did you guys get when you did 10.4 divided by 3.23?
I'm still working on it.
I messed up and I subtracted 10. I think you made a mistake.
Yeah, you what?
You made a mistake.
Did I make a
How do you
mistake?
make that addition after
It's
a negative?
It says 3.23. I think it's supposed to be 4.
What is it?
Nope, it says 3.23.
I think it's 3 point. Yeah, not 4 point. Because the 5.1 minus 1.8, the 1 minus 8, you're going to have to carry.
Do we do it?
Yeah. Yes, you may. Yeah, Cameron, what'd you get?
Can we round it up since it's a lot of this?
Okay, if you are making a choice, I usually say, like on your homework, I said 3 decimal places. So round it to 3 decimal places for me, Cameron. So what number do we have? 3 point what?
210.
210. So he rounded to 3 places. Okay, so leave it like that. Is it 3.13? I think it's 3.23.
I got 3.219.
It was what? 3 point what? 2. And then what?
98.
Oh, if it's 2198. Uh-oh, how do we round this then? If we're going to 3 spaces, so look here.
3.228.
So this 9 gets rounded up to a 0, but this needs to change to a 2. So it's 3.220. That should be your answer. Okay? All right, so let's try another one with decimals. Oh, I guess those were our 2 with decimals. All right, so let's try using the shortcut. So if we have the shortcut method, we're going to treat it just like we did with fractions. Okay, so we're going to multiply by what's the least common denominator. Okay, but really, as we're doing that, we're thinking about everything in their fraction form. Okay, so everything in the fraction form. So I'm going to have 25 over 100x
Wait,
minus
how do
7.
you do the shortcut if it's all decimal?
That's what I'm talking about. So we need to figure out what we do to get this shortcut. So I have 35 over 100 plus 12 like this. All right, so I'm going to multiply through by whatever's going to clear this. Well, what clears it? What would our least common denominator be? 100, right? So how do you think we can go from, we don't have to write this. How can we go from here and know that we're going to multiply by 100?
Because that's the only
How do we read these numbers? 25 hundredths, right? 35 hundredths. That's how we read decimals. What if it just had a point and then one number after? What would we multiply by? 10, because that's 7 tenths, right? What if I had 0.123? That's 123 thousandths. So what would I multiply by? 1,000, right? So we're multiplying by whatever we have the most of decimal-wise, okay? So we're going to multiply through by 100. And we know that when we multiply numbers by 100, we move the decimal place. How many times? 2 times, right? So I'm going to take this and I'm going to move it over twice. Well, what about this 7? It becomes 700, right? So I'm going to have minus 700 because that decimal place moved over twice as well. And then this becomes 35x plus 1200. All right, so we multiplied everything through by 100. Now is it easier to do? Sure, right? So now that you have, that's kind of weird, 700. So now we have this, we're going to subtract our 25x over, subtract my 25x over, so I get 10x. And then we're going to subtract the 1200 over, subtract the 1200 over. We get negative 1900 equals 10x. So when we divide by 10, do you guys know the trick where if we divide by 10 or 100 or whatever, we cancel the zeros? Divide by 10, divide by 10. So we get negative 190. Wasn't that much easier? Yeah, it's much easier. With decimals, it's much easier to multiply through. So on this one, this is over 100, and this one is over 10. So if I had 100 as a denominator and I had 10 as a denominator, what is the least common denominator? It's 100, right? You go with the bigger number. Okay, so we're going to multiply everything through by 100. So what will that do? That still moves the decimal over twice. So I'm going to have 2 places. So I'm going to have 40. Do you guys see that? If you need to write it out so you can see it, 1, 2, would put it right there, 40. And then I have minus, move it over twice, 125x plus 312x equals, how about here, 5.1. What's it going to change to? 510. We move it over twice, right? Put in a 0. So 510x minus, be careful, don't forget this one. Move it over twice. 1,000, exactly. And you can do all this work and you end up getting exactly the same thing. Do I need to do all this? Can I just say etc.? And what did we get? 3.220. It's the same thing in the end. But it's easier because we don't have all those decimals. All right. Everybody understanding this? You know how to clear fractions. You know how to clear decimals. All right. So you might also have some story problems. So number 7 says the perimeter of a rectangle is 312 centimeters. The width is 10 centimeters longer than the length. So when it says longer than something, then I let my whatever is after that be my variable. So I'm going to let L equal my length. So I'm going to have L, and then the other one's going to be 10 centimeters longer than that. So what am I going to write for the width?
W equals L plus 10.
Yeah, you say L plus 10, right? So if I'm setting up an equation to come up with the perimeter, well, the perimeter is adding up all the sides, right? So that top one is L plus 10, and the one on the left is L as well. So if I add up all these sides, I get L plus 10 plus L plus L plus 10. And that has to give the total perimeter, which is 312. Do you guys understand that setup? All right, you could also do 2 times the width plus 2 times the length. Have you guys seen that? All right, so we add them all up. So we're like, okay, I have L, 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 and L. I have 4 L's together. Plus 20 equals 312. And I subtract the 20, I subtract the 20, and I have 4L equals.
How are you getting 20?
Oh, I forgot to add those together too, didn't I? So 10 and 10 is 20. Right? Forgot to underline. So when I subtract it over, so let's think about it. Can you do this with mental math? If you have 312 and you subtract out 20, when you subtract 12 of those 20, you're back at 300. How much more do I have to subtract out? 8 more, right? So what's my answer? 290. 290 2. Yep. And then if I'm dividing by 4, remember when I'm multiplying by 4, I taught you a shortcut. I said multiply by 2, multiply by 2 again. Same thing with dividing by 4. So let's see if we can do it. If you divide by 2, ooh, a little tricky. If it was 290, it'd be 145, right? So we have 292. So it'd be 196 would be 2, dividing by 2 once. Let's do it again. What do you get when you divide 196 by 2? It's almost at 200. Not quite 200. Anybody can you do that in your head? What do you get? 98. You guys aren't fans of mental math? All right, now if you couldn't do it with mental math, you can always do it off to the side. You would just do your 292 divided by 4. And I would totally expect you to know how to do something like that on the test without a calculator. All right, so the final question is, what are the dimensions? So we have the length. So what's the width? I did something wrong, didn't I? It's not 98. What am I talking about?
73.
73? I don't know what I did there. Okay, so 73. I do know how to do that in my head, but I'm just having a Monday moment, apparently. All right, so I have 73, and then I have, what's the width? 83 then, right? 10 more. So when we write dimensions, do you guys know how we write dimensions? Have you seen this like at Lowe's and so on, like a 2 by 4, right? 4 by 8. So we're going to do 73 centimeters by 83 centimeters. There we go. All right, and then number 8. So a 20-foot long board is cut so that one piece is 3 times longer than the other piece. So we have this big board. We're cutting it. So the first piece is X, and the other piece is going to be what? Yeah. So X is going to be our smaller piece, so that means our bigger piece is going to be 3X. Now, could you do X for the long one and 1/3 X for the short one? Sure. Is it harder? Yeah, because you have fractions, right? So it's easier to make the X the shorter piece. And all of this has to add up to be the length of the board, which is a total of 20. So our equation is very easy. It's X plus 3X equals 20. So 4X equals 20. So X is equal to 5. So I have 5 feet. So I'm going to have 5 feet for the small piece. And how much is the other one? Yeah, it's going to be 3 times that, right? So 3X is going to be 3 times 5, which was 15. So 15 feet. All right. Okay, last question. Super challenge. Can you do something that involves lots of fractions and lots of decimals?
Yes, I can do it.
I think you guys can do it. I would probably be consistent. I would either change everything to decimals, change everything to fractions. I would change them, okay? So if you're changing everything, you would have 4 over 5x plus 8/10, right? Minus 1 and 12 hundredths. Oh, that's a little bit harder.
Wait, can you simplify it? Yeah, you can simplify this.
Do you want to simplify those numbers first?
Yeah,
Sure.
'cause they could all go into 10.
All right, so what do you want to do
But then
here?
it'd have to be 100.
Ah, Peter's using his brain. Do you guys hear what he's saying? So he's
Yeah,
like,
I
they would all be
confused myself.
10s for the denominator. He said they'd
they'd
all be 10 for the denominator, but the other ones, the decimals involve 100. So let's just go ahead and clear then. Let's not combine, and let's just make our least common denominator 100, right? Because all of those would be something over 100. So we're going to multiply every single thing by 100. Well, what do we get when I do 4/5 times 100? What's 4/5 of 100? Divide 100 into 5 pieces, and then take 4 of them. Yep, so it's going to be 80, right? Because this becomes 20 times 4. So we get 80x. What happens when I take 0.8 and I multiply by 100? I move it over twice, right? So I need an extra. So I have plus 80 minus 1.12 multiplied by 100. 112 plus 3/10 multiplied by 100. What do we get there? Cancel, cancel. 30, right? Equals 7/10 multiplied by 100. You guys are giving up on me, aren't you? 70x plus 1 times 100 is 100 minus 3.25 times 100 is 325. Does this look much, much easier?
Yes.
It does look much, much easier. So combine our like terms. So we're going to combine these three numbers because these three numbers do not have any x's. So let's take the positive ones first. I have positive 80 plus 30. 80 plus 30 is what? 110. 110 minus 112, what's that going to be? Negative 2. So I'm going to have 80x minus 2. Same thing over here. I have 100, positive 100, minus 325. What is 100 minus 325? Negative 225, exactly. I have everything simplified completely on the left, completely on the right. So I combine my terms. So I'm going to subtract my 70x over. When I do, I get 10x. My x's are away, right? They're gone. Equals negative 225. Don't forget that negative. Then I'm going to add the 2 over. When I add the 2 over, what do I get? What do I get? Negative 223, exactly. Equals 10x. So x equals negative 223 over 10, which doesn't reduce because 10 is only divisible by 2 and 5 and 1 and 10, right? It doesn't go down. Or if you wanted to write it as a decimal, what would it be?
Negative 22.
Yep, negative 22.3, exactly. I usually like the fraction form if possible, but if you want to do the decimal, you may do that as well. All right, let me pass out